So we have the method dependencies, and the number of classes is given to us, it's 5. So the very first step is to find the class split, which is the maximum value minus the minimum value divided by the number of classes that we want. The maximum is 51, the minimum is 32, divided by 5, 19 over 5, that is 3.8. We always round up. Now, some people say round it to the nearest integer. Some would say always round up. Your book, I believe, says always round up, and I'm going along with the book. In practice, there are multiple ways to get to an accurate frequency distribution. So I'm going to round up. I'll put a note here. So we are going to come up with pungency intervals. As I mentioned when I did class split, some like to start one below, some like to start at the smallest value and include it in the class. Your textbook starts at the smallest value. So 32 up to 36, I'm adding 4. Start at the next value. 37 up to 41, 42 up to 46, 47 up to 51, 52 up to 56. But if everything works well, you would get 5 classes, the desired number of classes. Yes.
Is it still normal to have a class that's greater than the maximum value though?
It is possible, yes. It's normal. And a related example would be, there are cases, say, when we measure time, time cannot be negative, right? So you start at 0, and sometimes the lower limit might get into negative, at which point you just use common sense and say, I'll just terminate at 0. So we are going to include those values. So 32 to 36. So 1, 2, 3, 4. 37 to 41. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10.
You're missing.
I'm missing 38 and 39.
And 40.
On the third row, you're missing 2. Yeah.
30. 42 to 46. 1, 2, 3, 4, 5, 6. 47 to 51. I have just 1. Last case is just 0. Good. So those are the frequencies. Are these class limits or are these class boundaries? Class limits. How do we get class boundaries? 1.5.
0.5.
0.5. Yeah.
What's the difference again between a limit and a boundary?
You're adding and subtracting 0.5. So you would add 0.5 to the upper limit, subtract 0.5 from the lower.
Space between the books and this boundary.
So we have the class boundaries, and this is what I want you to do. Find the midpoint, the class midpoint, and the relative frequency. So class midpoint. Just have to add these two and divide by 2. So that would be 34, 39, 44, 48, and oh,
49
yeah, 49.
and 54.
We can add the cross boundary to and see the same.
Yes, you read my mind, because that was my next question. It really doesn't matter whether you find the midpoint of this or that. Mathematically, they are the same because you just added it to practice. So relative frequency. We take each frequency and we divide it by the total. We know the total is 24, so we have 4 over 24, 13 over 24, 6 over 24, 1 over 24, and 0.
Do you ever get this to simplify that? Or just leave it as is?
So typically we would want a decimal number in most cases.
Okay.
Because relative frequency is a term that we use now, but relative frequency is nothing but probability.
Right.
And that's what we're going to use.
Okay.
So the question that I'm going to ask will make sense as to why we want it. So what are the chances that if I went to the grocery store and I picked a Tabasco pepper, its Scoville unit would lie between 37 and 41.
40 what?
37 and 41, or from 37 to 41. 13 over 24, right? Now, I can understand that, you can understand that, but if I, explain it to someone, yes, it is going to be 13 over 24, no one's going to understand that. This is where we convert it to a probability. That is probably about 55, 55,
54. 54%.
54%. So there is a 54% chance that if I pick a Tabasco pepper, it will have a value from 37 all the way up to 41. This is a random sample because even though they're all Tabasco peppers, not every pepper is going to have the same spiciness, right? So it is going to vary. But majority of them, or all of them, lie in this range. So if someone came up to you and said, oh, I have a Tabasco pepper and its Scoville unit is going to be 22, would you agree with them or you completely disagree with them? Disagree, because data is telling you that it has to be between those two values. Strictly speaking, here 32 to 31. Does that make sense?
Yeah.
Okay.
And the
Last thing that we're going to do is cumulative frequency. Let me make that clarification here. Cumulative frequency, the verbiage is kind of fuzzy. Some would simply use this and call it a cumulative probability or call it a cumulative frequency. Some are very strict and say, okay, it is a count, so it has to be the count. So right focus then, you will see the difference. So cumulative frequency simply means you're going to add, everything up to that class. So nothing is below that level, so the starting level would be 4. 4 plus 13 would be 17. 17 plus 6, 23. 23 plus 1, 24. 24.
We don't have to put over 24.
You can't. You have only 24 peppers. It magically come up with 1. So the maximum is 24. Now, over here, cumulative probability is relative to the total. So 4 out of 24, 17 out of 24, 23 out of 24, 24 out of 24, 24 out of 24, which is just 100%. And always keep in mind, cumulative probability means at most less than or equal to. Yes,
You put cumulative probability in a decimal, or would you leave it?
we can.
Like what's usually?
In practice, decimal. Okay. Last time we did the ECDF frequency polygon, relative frequency polygon, using the calculator. Now, when we computed or when we graph the relative frequency polygon, what columns did they use here to come up with that graph?
Cumulative frequency and upper endpoint.
We are talking about a relative frequency polygon, Alex.
Then midpoint and class boundary.
The relative frequency. And.
Midpoint, so which
Yeah,
goes where?
midpoint.
This axis would be, the x-axis is
Oh. Midpoint.
midpoint, so class midpoint would be x. And relative frequency would be y. If it is a cumulative frequency distribution or cumulative distribution function, empirical CDF or jive, one of those, then what is the x-axis?
Oh, the cumulative, the cumulative
Upper
probability.
endpoint,
X-axis.
the upper endpoint.
Upper end point of here or there,
Boundary.
upper half boundary. And it is a matter of choice. Some would plot for cumulative probability, some frequency. If you ask me, well, what would you go for? I would always go for probability. As I mentioned the very first day of class, probability is the most important measure in statistics.
What's OGIT?
Not OGIT, it's OJIVE.
Okay, what's that?